Welcome to our class. Today we are going to learn on how to draw isometric figures, and I have a small picture to at least guide us on how we are going to draw it. Now if you have a figure as this, remember this is an egg paper, and if we have a figure like this, so you see that we have the dimensions that are indicated, and the easiest way to approach this question is at least get the dimensions of the entire solid. If we measure this line here, for it to make us to know whether it's isometric, this would be 30 degrees and 30 degrees, which we want to produce. Now let's look at the dimensions. This tells us that this is the height, this also the height, this would be our length, the entire length, and the width. So get to know all the dimensions, that is the length, the width, and the height of your diagram. This will help us get the entire box that we're going to draw. We call it an isometric box. Now in our measurements, we are having 20 at the height and 45. So that tells us the complete height of this cube or this solid is 45 plus 20, which is 65. So we will have 65 is our height, and along the length we have the largest length is 65 as well, so this would be 65. The width would be 50. So our isometric box inclined at 30 degrees on the sides from the base would be 50 by 65 by 65. So let's proceed and draw this diagram in isometric. Now let's draw our line to guide us in drawing the angles. Then pick your set square of 30 degrees. You're going to draw those angles, ensure it's in line. So rotate it as this to make it very simpler. So the point where your line crosses, that is the point we're going to draw 30 degrees angles inclined. So that is procedure number one. Set that you love this angle as 30 degrees and this other side as 30 degrees. What are our lengths? The figure that we had our length as the length is 65 by 50 by 65. So we're going to draw that and get an isometric box. 65 by 65 and 50. So we have already determined the length, that is of 65, and the width of 50. Now we're going to raise the verticals, rather for the heights. You can use your pair of compass. Use your pair of compass and erect those heights from the 5th or the 50th point. Make sure it's faint. We do all those from all the corners. Erect those perpendiculars. A height. Remember our height was 65. Make sure it's perfect. And to get a very good diagram, you make this one faint, so we'll have our outline with HB. So the height was 65. So proceed and measure the length of 65 using a ruler. 65. So that is my 65. I'm bracing and making very small arcs. Very small arcs. Identify those in your diagram. 65. Now proceed and join these arcs. So you can use your ruler as well. Just take your time. Do that. Let's do the same on this other side. Okay, you're very accurate because those points were very light. Good. So you realize that it's not complete. We only have two faces. We need to also get the plan here. So we need to join to have the complete plan. Let's now complete the entire plan by its hanging, and our isometric cube is not supposed to hang. Let's complete it. Break that. make use of your set squares. Just make use of your set squares. This was 30 on directed vertical. So remember, my lines are very faint. So that's the entire cube. Now I'm naming it for the purpose of illustration. So I'm having A, B, C. Let this be point D. Let this be point E, and then F. B can have this point as G. Point G. Now we have a height of 20. Let me bring my diagram a bit closer and be able to observe it. So we have an height of 20. That is from point C. We'll have an height of 20. So get the 20. You can use your ruler and identify the height of 20 from point C and put that a dot. Remember that line is parallel to GD. It's parallel to GD. So isometric should be one of the interesting drawings because it's simply playing with your rulers. GD. So this was my point 20. They need to be parallel. The same along BA. We still have a height of 20. So just if your set square is well set, you'll be able to produce this one very clear. So that is it. So we already have this base from our drawing. So the base here for the height 2020 is what we have in our diagram. Now we're going to erect because you can observe that we have a very thick line on vertical, but it's not complete. For my diagram, it's complete. So from point A, we're going to at least measure the length of 45, where the 45 fits in, and this line is parallel to the AB. So please get your ruler and read 45, the height of 45. Remember the height of 45 from point A. Just take your time and make sure you are accurate. 45 millimeters. 45 millimeters. That is the point. Use your ruler, your T-square, and a 30, so it should be parallel, but very slight. So, and that one is the length of, from our diagram, the length is 20. So from 45, we're going to at least identify where the 20 point is. And maybe below that, we can get back to the base that we drew initially. So from here, I just identify the 20. That one will be very easy with our ruler. 20. This is my point 20. From my point 20, I'm supposed to erect a perpendicular to meet the line that we drew from 45. From 45. That is it. So, from our diagram, we already have drawn this face. Interestingly, we have this line which is parallel to line BC. So, from our point 45, we're going to draw a parallel line which parallel to B and C. Line parallel to B and C. So it's still 30. This was my point 45. Point 45. So this line is parallel like that. Don't be limited. Just take your time and draw that. So those are lines parallel. But could we please identify the length? The length from 45, you can have a look that from point B, the entire width was 50. So here to here, you don't have the dimension, but we are given 20 on the top part. So that tells us that the remaining is simply 50 minus 20. 50 minus 20, that is 30. So this length would be 30. From point 45, now let's identify the length of 30 to be able to get this line here. The length of 30. Simply use your ruler. Identify the length of 30. I exaggerated mine a bit. So let's draw that. It will have a parallel line. That. So your 30 is here. Very good. Now, the face we are seeing, that is of 30 by 20, is this face here in our diagram. 30 by 20 is this face. Now we need to erect another face here. If you can be able to see this part clearly, we have the height of 20 and we had initially 45, and our height was entirely 65. So the remaining would simply be 20. Now we're going to draw the 20 from the 30 length. We're going to erect the 20 to touch the entire part of our isometric box. So just erect a perpendicular. Erect a perpendicular there. Should be height of 20. So this perpendicular here is 20. So in our diagram, let me name this point E as well in my question so we can be able to identify. We've already drawn the face here and this other one to the point 20. So this height is 20. Now the remaining is 20 as well because we add the entire length of 50. So from, let's say, point X to E is 20. X to E is 20. And from point E, I love to draw a line of 30, and that, because we already have this as our vertex, we're simply going to measure the length of 30 to be able to draw this face of 20 by 30. So this is the vertex, so we really have this line for our isometric box, but this is the line we're missing, which we are going to produce from point X, and this line X is simply parallel. Now let's measure the length of 30. Length of 30 from point E. Length of 30 from point E. So that is my point 30. This is my point 30. We need a line parallel from point X. Now pick your set square. Your set square from point X. Point X. Draw that line, and instead of measuring 30, because you already have point 30, you can just turn it this way because it's an angle of 30 to guide us. So we're going to fill this from point of 30. That is it. So whatever we've drawn is this face in our diagram. It's this face entirely in our diagram. So point XE is shown of 20 by 30. Now we need to drop this length here from point 30. Remember, it's touching our width from the erected where we had already drawn the 20. So observe it well in our diagram. We add point D and point C. So the length between C and, let me call this one S, is 20. And S is simply drawn to connect, let me call this point Y in my diagram. Y in my diagram. So I'm going to simply draw that line because it's not straight, but rather it is line drawn to join the 2 points. So we're going to simply join that from our diagram. So it's from this point Y to point S, Y to S, Y to S. It's still construction. I don't want to make it very faint. We'll have the faint as the outline. From point S, we have this dimension, and this dimension is 20. Entirely is 50. Well, we can simply read it from the top of 20. That tells us the length XE is 20. Then let's say OY is also 20, and that will translate point M to S to be 20. So we're going to measure the length of 20 along from S, the length of 20 from S. Length of 20 from S. So that's my 20 point from S, let me call it M. very faint. Now I'm going to join point M to O. So we're joining that line of M to O, M to O. So from our diagram, you can see that the face OY, M and S, face OY, M and S is what we have drawn. This is point O, OY, M and S. This is the face that we were really looking for. Now we've not identified this face here. The face have at least shaded it. So we need to identify, and that is the only remaining thing for us to complete our isometric figure. Now, from point M to B, we already have that line. So we're going to draw a line parallel to this on this other end from our diagram. So at least extend that. So from point M, we have a line parallel from point M. So simply use your set square and a T-square for that purpose. From point M, we have a line which is parallel. We just draw that line parallel. And the length, we need to identify the length. It's 65 entirely. For all length, it's 65. But then we are having a length of 20. So we simply have to subtract 20 from 65. So 65 minus 20 is 45. So this length would be 45 millimeters. The length is 45. Our length of 45 is here. So that is 45. So you could have as well gone a simpler way of dropping a vertical line from this point which would intersect with your 45. Whichever way works better for you, could as well have applied it. For my case, just decided to take the measurements. Now I'm going to draw that line. So you've already drawn that. Let's finish our drawing by filling this face here. Now the remaining thing is now to bring the outlines. We have all the lines that we needed. Let's now bring in the outlines and see what we are going to have. Now we have the two lines. Now let's finish the outline. We have this shape in form of L, and in our diagram this is the shape, the L. So we're going to draw this as an outline, and that will require you to use your HB. So finish that outline. Maybe you can pause the video and at least do the finishing of the outlines in your own drawing. You're doing the L. This should be HB. It is the outline. So that is the shape of my L. I hope your diagram looks the same. We also have this face, which we're going to put it as an outline. So this is the required face here. So you do that one as well in your diagram. Draw this. Finish that outline. That is what we are looking for. So this face is what we have drawn right there. There is this other rectangle here, which is this face. Yes, so that's another outline to be drawn. Draw it as that. It's very simple. Remember, it's tracing where you have drawn initially. So this should not really disturb you. This is the face we were drawing. Now we have this other shape, this rectangle as well, of 20 by 50, which is here in our diagram. So you're going to finish this outline as well. If you're following clearly, then your drawing must be very perfect and neat. We also have this slant height, the slant, which is of 20 by 20. So not 20, but it's simply of the length 20. In our diagram, it's these lines, the two lines, and of course the length of 20. So finish that outline with an HB. Finish the two lines. And this other one here. The remaining is the top face, which is in form of a rhombus, like here, of X, E, or Y in our diagram. X, E, O, Y. Remember, it's all about isometric. So there is this one height remaining. We're gonna fill it as that. So that is the entire drawing that we were required to draw. So this is the isometric figure that we really require. The whole faces are indicated as shown, and I really hope you have achieved the same in your diagram. Thank you for watching. I meet us as well in our next class.